Right, we're going to look at this magnetism worksheet, if we can. Some nice questions in here. Right, you've got a magnetic fields shown, A, B, C, D. Well, which one of these is a uniform magnetic field? So, right, it's pattern D. Why? Because the lines are parallel and evenly spaced. Right, explain how to produce a uniform magnetic field. What you do is, this is it, just learn it like this, yeah? Take two permanent magnets. Have them facing each other with opposite poles. So for example, you've got one here, that's north, and then you've got here south. And remember we said magnetic field always goes from north to south. Yeah. Right. These lines are straight. They are parallel. And they are equally spaced. There you go. And they've got to be the correct distance apart. You can't have them too far apart, and you can't have them too close because they'll just attract each other. I think that's it, yeah. Okay. So what can we say here? What note shall we make here? Right. For a uniform magnetic field, we need the lines have to be straight, they have to be parallel and equal distance apart. Right, we also know the magnetic field goes from north to south. Okay, always go from north to south. Okay, that's it. That's good. So we learnt them two things. Right, you've got a rechargeable torch. When a student shakes a torch, the magnet moves across or through the coil and back again. This induces, these are the key words, right? This induces a voltage across the coil ends. The voltage is used to provide current to recharge the battery. Right, so you've got a magnetic field here. Just say you've got a magnetic field like this. And because the magnet's moving, what's happening is it's cutting across the coil, and so the coil wire is cutting across the field lines. It induces a voltage, so then current can flow. Right, so we now need to say that so the magnetic field in the magnet cuts the coil causing an induced voltage. Then that voltage drives the current. Right, okay, let's keep going then. So the diagram shows, so look what we've said here as well. Let's make a note of that. It's important we make a note of that. When a wire or coil cuts across a magnetic field, it induces a voltage. It produces an induced voltage. Then this allows the current to flow. So just pay attention to this. So wire cuts across a magnetic field. It induces a voltage. It's a good one to remember that. I've seen that in a lot of exams. Okay, right, let's look at this one. The diagram shows a piece of card and two wide bar magnets. Right. Add to the diagram to show the shape and direction of magnetic fields between the magnets, north-south. So remember we're going from north. Not with that really. So let's do that. Goes from north to south. 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 That's it. Done. They want at least 3 lines. We've drawn 4, equally spaced. So what you would do, on the day, you make sure that these are roughly, using your ruler, put them maybe 1 centimeter apart or half a centimeter apart, but draw a few. Describe how to investigate the shape and direction of magnetic. Right, okay, this is like an experimental recall. So first thing you do is between the magnets. So what we do is place a card over the magnets. Sprinkle on filings. Sprinkle on filings. What do you do? Sprinkle on filings on card. Sprinkle on filings onto card. Tap the card to reveal the shape of the magnetic field. Okay, so we've done done that shape. Now we want the direction. So what we do is we get a compass. Place. So you place a number of what we're going to do, place a number of what? Place a number of compasses on the paper, on the card, to show direction of field. I think that's it. That'll do it. Yeah. Right. A metal rod. Okay. Metal rod is placed in a magnetic field shown. Wires from the cell are connected. So the current is going. Should we use another color? The current is going in that direction. That is current. The field lines are going. They're going in that direction. So that is the magnetic field. And we want to know what the force is. The force or the motion. So remember, this is Fleming's. Oh, did I just put that? Left hand rule. Right, let me go get that. Right, there's the Fleming left hand rule. Thumb is the motion or the force. First finger tells you the direction of the field, and the second finger shows which direction the current's going in. So this is how someone told me. So look, what I'm going to do is I'm going to copy this over here, right? So that's your thumb. That's your thumb. So that's your father. Your first finger's your mother, and your third finger is in that direction, is your child. So that's your force or motion. This is your nova. This one's current. I know I got them two the wrong way around in my head. Father, mother, child. Force. So your first finger. Right, okay, it's mother, father, child. I always forget this. So look, mother, father, and child. Mother is your motion, and that is the field, the magnetic field.